For this lab, we are going to be configuring static routing using IPv6. Again, we're going to be configuring static routes using what? IPv6. IPv6. As you can see, I have already mapped out my network address and IP address for each of the various links. We have for router 1, which is the very first router here. We're just going to call it R1. I also have another R2 here also. So we have router 1 and router 2. We're going to go over the basic IP address assignment. That way it refreshes in our mind as to how to assign an IP address, an IPv6 address to an interface and also to a host. It's pretty straightforward. Just for ease of convenience, I'm going to be copying my IP address. I'm just going to copy here and go to my host computer. Also on my desktop, IP configuration, and I will select IPv6, which you already see here, which is static. I'm going to assign an IP address to this interface. We said the IP for this router is .2. For this host is 2. So the subnet mask end is going to go after. See, well assigned. I'm also going to be assigning the gateway for this host, so we can do everything all in once. The gateway for this is what? 1. As you can see for the interface here is a .1. So I'm done assigning the static IPv6 to this host. I'm going to move to the next host, and I'm also going to do the same thing. Just going to copy and go into the computer, the desktop portion, IP address, specifically the IPv6 section, and I'm going to enter this subnet mask, and I'm also going to enter the gateway. Okay, all that being said and confirmed, we're going to go into our router 1 now, and we're going to assign IPv6 address to the interface. We're going to assign IPv6 address to the interface. I'm going to open up a small notepad. That way we could have the commands easily visible for us to see. So this is my notepad. I'm going to start by writing router 1. This is for router 1. Alright, so that's for router 1. It's going to be so enable config C, then hostname R1. You just want to do those basics, and we already understand the preamble, so I'm just going to go straight and configure the interface. Interface G0 of 0 of 0. I'm going to assign IPv6 address. I'm going to be using the IP address here. Let's see, I'm just going to copy it. I like to do these things easy, so I'm going to copy the IP address and just paste it. And okay, 64. And don't forget the IP address for this is 1 and not 2, so 1. Awesome. Then I'll go to the next interface, interface G0 of 0 of 1. Okay, we ignored no shot. Let's look up the interface, no shot. Awesome. So interface G0 of 0 of 1, no shot. IPv6 address. Just gonna copy. and it's not 1 also. Okay, that's for router 1. Just go a little bit down and let's go do that for router 2. I'm just going to replicate the same solution and replicate it for router 2. So I'm just going to copy this and we're going to edit it to make it easy for everyone. So this is router 2, enable config hostname is going to be router 2. The address did change and this changed to 3. And this also changed to 3. As you can see for router 2 internal host. And this is for router 2. This is the G00 of 1 interface, like you can see here, having the 33, and the G00 for router 2 is 12.12.12.2, as you can see, G00 offset. So before we start configuring our IP route, IPv6 routes for static routing, let's copy all of this into our router and be sure that our host can reach their gateways. So I'm going to go into my router now on my desktop terminal. Okay. And I will be copying that command into my router. Say no, enter. Oh, I made that's a mistake from my end. Just going to tab it. Okay, or aborted that command. So just going to copy. I think we already copied this command already. I'm just going to paste. Let's see, did it take it? I guess it took it. Let's be sure. Yes, it took all the commands for router 1. You can see our interfaces are up. Then let's go for router 2. Let's copy the same for router 2. Copy for router 2. I'm going to move my console cable temporarily to the console port of router 2 and go back and verify my configuration is properly set. So I'm just going to right click and say paste. It took the command also router 2. As you can see, all the interfaces are lit up and they are all green. Easy peasy. Okay, just for verification, I want to go to my host and go to my command prompt and try to ping my gateway. Ping my gateway. My gateway for this router, my gateway for this internal host on the router 1 is going to be 2001 column DB8 column 2 column 2 column 1. All right, let's see. I can see I get a reply, meaning I can reach my gateway, which is a .1. So that's proof that our hosts are communicating with their gateway. But if I try to ping across, definitely it should be unsuccessful. It should be unsuccessful because we don't have routing in play. But just to give it a shot, I like to push my luck sometimes. Let's see. You can see we have no routing in play, so it's definitely not going to work. Just going to hit cancel and stop that quickly. Now we can go back into our router on our command prompt and implement static routing for IPv6. I'm going to go back to my notepad. And since we are starting from router 2, but it doesn't matter, I'm going to go to router 1 and say configure the IPv6 routing. I'm going to configure IPv6 routing for router 2. That way I can see everything I need to do and all of that. I'm going to configure IPv6 routing for router 2. All right. So all I need to do is just write out the commands here. I'm going to start from router 1. Still the same formula. IPv6 route. You have to put your IPv6 route to differentiate it from IPv4. It's super important. IPv6 route, I'm going to write the IP address, which is our destination. Our destination from router 1 is going to be the internal host of router 2. That's the internal network of router 2. That's what I'll be pointing it to, which is DB. It's like a star. Like I'm cutting over like a star. Just like the default static routing we have learned, in our previous class. So 2001 db8 column 3 column 3 column slash 64, because I'm pointing it to the entire network. Okay, so this is IPv6 route, destination, network, and mask. And it's going to ask us for the next hop interface. Where is it going to pass through? It's going to come through from router 1. It's going to hop to router 2's interface. And the destination interface is going to be the destination network, which is dot what 2. So I'm just going to move this and add it to my command and say paste. I'll come back and edit this to 2, because it's going to hop from 1 to 2. So that's the IPv6 route for router 1. Just going to copy and go back to router 2 and add it. So just that this time we're going to modify the internal network is going to be 2.2. Oh, okay. And this time it's going to pass through 12.1. It's like going vice versa. So that's what we did. So this is my static routing command, and just going to give it a little title and say static routing, static routes. Okay. So let's copy and put them in our routers and let's see what happens. So I'm copying this for router 2. Just gonna, I like to do exit. I'll return to my global configuration mode when pasting new commands like this. So let's copy and paste and hit enter. Awesome. So I'll go back to router 1. I'll move this a little bit. Come back to router 1. I'm also gonna move the command and come to router 1 and paste it. Awesome. Exit. Router 1. Copy. Paste it. Enter. Now I'll have static routing. Let's verify just to be sure. I'm going to save my work real quick. Copy, run, start. Okay. Now I've saved my work. Show IPv6 routes. To verify if static is there, you can see static routing has an interface distance of 1 hop, and this can see what network is seeing 3.3, which is this host, the 3.3 network, using 12.12.2 as seen clearly here. Meaning that if I should ping from this host I had tried earlier that failed to work, we should get a reply this time. Okay, let's see what's going on. Let's do it. Okay. We should get a reply. We should get a reply. Okay, let's try one more time just to be sure. Let's try one more time to be sure it's working, because okay, so we just verified that our static routing is working. We could ping across from this host to the other host. Let's try the vice versa and see what happens. I'm going to show a ping 2001 column, okay, db8 column 2 column 2 column 2. That's the host IP. See, we can also go back from 3.3 and ping 2.2. So that verifies our static routing is working. So it's just a very straightforward and simple app to set up static routing using IPv6. Okay, we're also going to add a different protocol to this lab we just did. Also going to learn about OSPF using IPv6. We'll be configuring OSPF using IP version 6. OSPF using IP version 6. OSPF is a little bit different because for OSPF, we'll have to define the interfaces and everything. But just know that you can actually configure OSPF and also configure static routing on one router. But the idea is that the router is going to prefer the static route over the OSPF route because of their administrative distance. Static routing has an administrative distance of 1, while OSPF has an administrative distance of 110. And it is said that the lower the administrative distance, the more reliable the routing information is. So it always prefer static over dynamic, which is OSPF. Just wanted to put that somewhere and always remember that. Administrative distance are used to make routing decisions by these devices because they want to get to their destination over a faster means, or a closer or more reliable route. Moving forward, I'm going to add OSPF to this configuration. So we're going to also be configuring OSPF using what? IPv6. IPv6. I'm also going to configure OSPF using what? IP version 6. Just going to put a bar in between to separate it, showing that we actually did 2 labs. All right, OSPF. So I'm just going to proceed and configure it on my already existing lab. Okay, I'm going to configure it on my already existing lab. And we just proceed forward and we'll test out the configuration. So I'm going to enable. To configure OSPF is straightforward. Like I said, you have, unlike static routing that we just went forward and there are certain variables you have to define when you want to configure OSPF. We had looked at this earlier, but for IP version 6, number 1, you have to always define the loopback ID. The loopback ID. OSPF is heavily dependent on loopback ID, especially when it comes to IPv6. Loopback ID. Sorry, you need to configure. I keep calling it the loopback ID. Let's call it the router ID. And how do you configure the router ID? You have to go configure a loopback interface, which is always preferable when assigning your router ID. So to configure router ID, the loopback is always what? Loopback is always preferred. When configuring the router ID. Okay. Another important thing you have to also decide for OSPF is that you have to understand the area, because this is just a regular OSPF. I'm going to be using area 0, which is the main backbone area. Also, you have to define your process ID. Process ID has to remain the same for Unism, and also to allow the routers under OSPF converge faster. Okay, to converge faster. We have over 65,000 process ID, so choose the one that is best comfortable for you. For this lab, I'm going to use process ID as 1, just for ease of configuration. Now I'm going to proceed. I have 2 routers, so I'm going to define my router IDs. I'm going to assign 1.1 to 1.1.1.1 as my router ID for router 1. And I'm going to be assigning 2.2.2.2 as my router ID for router 2. Just for easy, naming conversion or something. That way it's easily recognized. So I'm going to go back into my router now, and I'm going to go to interface. Straightforward interface loopback. Okay, why don't we do this on our notepad? Then we transfer it into the router. Okay, so I'm just going to put a delimiter here and say OSPF IPv6 or OSPFv3. Okay, so you have to go into your interface and say interface loopback 0, and you define the IP address. So I'm going to say 1.1.1.1 for router 1. I'm going to 0, so maybe /24. All right. Then what else? I'm also going to go to under my interface of my routers and also advertise OSPF. I'm going to say interface. I'm going to say interface F0 of 0. Okay. So interface. Let's specify our interface properly. So I'm going to define the OSPF under each of these interfaces. So it's going to be interface F0 of 1. I'm going to define my OSPF under it. So that way I have an idea of what I'm doing. Okay, so I'm going to go under the interface F0 of 1. I'm going to say IPv6 OSPF. Process ID is 1, area 0. Area 0. I'm going to go under the other interface because I think we have two interfaces there. It's going to be interface F0 of 0. Yes. IPv6 OSPF 1, area 0. Correct this. Then I can now go into my router, still inside my router, and go define the OSPF process. So it's going to be IPv6 router OSPF 1. I'm going to define my router ID. Simple as that. That's all you need to worry about, and we are done. I'm just going to replicate the same situation and copy this. And we'll add it to router 2. Then I'm going to duplicate the solution. And for this time, our router ID is not going to be 2.2.2.2. And we're going to have, we still have F0 of 1 here. And we also have F0 of what? 0. So it's pretty the same. Just that when you're defining your router ID, don't forget to change this towards 2.2.2.2. Alright, let's give this a shot. We're just going to copy this quickly. I have to copy it systematically, that way I don't disrupt my, so you can understand the configuration properly. So I'm going to copy that of the interface first before copying the OSPF routing itself. So let's take this out. Just going to do control paste. Let's see. That's it. Then I come back and copy my IPv6 OSPF routing command and put it on inside, add it to the configuration of my router. So exit, the standard practice, like I said, paste, hit enter. It said reload or use clear IPv6 OSPF process for this to take effect, right? For this to take what effect? So we're going to reload this or clear it. We can either reload the router or clear it, but I like to use the clear IPv6 OSPF process. But I want to make sure I configure that of the other router, then I can come back and do it. Or you could just come and say, let's just let's save it and IPv6 OSPF process. You say you want to reset all IPv6. Yes, say yes. I'm going to detach it and I'm going to reconnect it. So you see, I say, let's save our configuration quickly. I'm going to come back and explain. You can see, I'm going to come back and explain shortly. So let's go to router 2 and verify that. Okay, go to router 2, go to our terminal, Control C, hit enter. I'm gonna hit configuration, config T. Oh, sorry about that. Enable. Um, enable. I'm gonna copy the configuration I have here for router 2. I'm going to copy these interfaces quickly. This is what we need here. And this is what I'm going to copy. I'm going to give this a shot. I'm going to copy everything from scratch. Let's see what happens. Let's see what happens. I'm going to copy everything on router 2. So to actually copy everything, I have to exit and go back to my privilege, my regular mode, just the regular mode, this mode, and say paste. Oh, did you take everything? We got one error anyway. Invalid marker detected, but that's probably because of this line. But I'm assuming you took everything. Let's see. Yes, it did take everything. It took everything. See? Router. So awesome. So I'm going to hit exit. I'm going to do the clear OSPF. Clear IPv6 OSPF process. So I'll say yes. So now you can see it's seen an adjacent neighbor on router was 1. So router 1 is an OSPF neighbor. You can see neighbor is 1. Just to verify that neighbor is 1. Show IPv6. Show IPv6 route. Show IPv6 route. Interestingly, the router is still preferring static, as you can see, which has an AD of what? 1, right? But see what's going to happen. I'm going to decide to take out my static routing just to show you that OSPF is still present in this router. I'm going to go into my command and say no IPv6 route. I'm going to take out the static routing for router 2. What's the static routing for router 2? Let's see if we can remember the static routing for router 2. It's right here. It's a no IPv6 route, this from this. But I think I also have it here. So let's go verify. No IPv6 route. This is for route. Just going to copy this, copy. Let's take out the static routing. So you can see that OSPF is just behind the scene waiting for static routing to fail so it to take over. I've taken out the static routing. I'm going to show you something funny now. I'm going to do show IPv6 route again. And you see that the OSPF is going to show this time with an O. See OSPF is showing now? Awesome. With an admitted distance of what? 110. So you see, right now we are using OSPF to communicate across the network. Let me verify that by doing a ping again from this host to the neighbor 3.3.3.2. Okay, that's it. So static routing and OSPF can work seamlessly in the same router using IPv6. We also have other protocols like AIGRP and RIPMG that you can also do configurations for. But because we are sticking with our CCNA curriculum, we don't want to go into all of that. So thank you for watching. I'm going to be sharing this. I'm going to be sharing the notepad for this lab and the lab itself and the video attached to it into the OneDrive so you could download it and access it. It's going to be uploaded into the recording folder as we usually do, and you can pull the configuration and the lab, including the video, from that folder. Thank you so much and see you in our next class.